climate change is a very big threat to a lot of species. Can they move? How many companies are responsible for, what proportion of the world's greenhouse gas emissions? That is also, those can be some staggering figures. The US is way, way up there in terms of impacts,
Mm.
and many, many creatures, evolved in isolation. And now they're being hit both by predators they can't deal with and by diseases they can't deal with. Many slash most of them are in a lot of trouble because of rising water temperatures. It will have tremendous effects on the many, many, many countless species that rely on reefs. A lot of the science is focused on, what is going to happen to the Greenland ice sheet. Greenland is already a major contributor to sea level rise, and the question of, how much more. The US government don't appreciate a lot of factors about Greenland, one of which is it remains extremely difficult. If you look back in the geological record at what, at times when you had extinction rates comparable to today, they were not happy times for planet Earth. 3 degrees C, because 3 degrees C is a very different world, really, really dangerous, scary world. And there are people I respect a lot who say that would be a disaster. Nuclear also raises, nuclear proliferation issues.
Hello, everybody, and welcome to another episode of Science Talk. I'm your host, Dr. Mohammed Ittefaq. Today, we will be spending some time to inform people that if you want to be well informed about our small, beautiful little planet, you need to read a recent book which is written by a Pulitzer Prize winner journalist, Elizabeth Kolbert, the book called Life on a Little Known Planet Dispatches from a Changing World. So today we will be spending some time by talking about climate change, nature, and biodiversity. Elizabeth has been writing for the New Yorker. There's a New York Post, there's a New York Times, and there's a New Yorker since 1999. She has received several awards for her recent books, and today we will be talking about her recent book, Life on a Little Known Planet and Climate Change. Elizabeth, good to see you and welcome to Science Talk.
Thanks for having me.
So my first question, I always struggle with this, but so what is happening? That's a more broad, general, light note question. What is happening to our planet and why are we doing this?
Well, I think in a nutshell, uh, what's happening to our planet is it's changing very, very fast.
Mhm.
Um, on a geological scale, so not just on the scale of, you know, humanity, a human lifetime, um, but on a geological scale, this is a very unusual period,
Mhm.
very unusual rates of change in many different spheres. And if you trace all of those back, so for example, the climate is changing, the oceans are acidifying, the surface of the earth is being changed very radically. River flows are being changed very dramatically. A lot of chemicals that didn't used to exist are being added to the atmosphere, to the water and the air and the ground very fast. All these things are happening, and if you trace them all back, of course, they get back to, one species, and that is our own.
Mhm.
So that is, in a nutshell, what is happening to planet Earth right now.
And who's responsible for all of it?
Well, humanity in general, obviously. Once again, obviously, some parts of humanity are much more responsible than others. But the generalized trend of, modifying planet Earth is pretty much universal, pretty much global at this point.
So when you say not all of us are equally responsible for it, some of them are more responsible than others, are you referring to countries or the companies or societies? Who are you referring to?
Well, you could split up that pie, sort of however you want. You could say obviously high consuming individuals who, tend to be concentrated in the global north, but not exclusively in the global north. High income people tend to be, high consumers and so therefore contribute more. You could trace it to certain companies. People have done calculations of, how many companies are responsible for, what proportion of the world's greenhouse gas emissions. That is also, those can be some staggering figures.
Hmm?
So you could slice it up by country, in which case, The US is way, way up there in terms of impacts. China at this point is way, way up there in terms of impacts. So there are lots of different ways that you could skin that cat, as it were.
So, your book, the recent book, and you have a couple of talks recently at different places. Not the talks, but like podcast conversations. And I loved with Daily Show on with Jon Stewart. That was a hilarious
Thank you.
conversation. I do think because sometimes these conversations are very dry, as we are speaking now, because a lot of people lose interest. But if there's a humor, maybe people are tuned to that, right? So. I'm going to ask you about a little bit about biodiversity. You interviewed Professor Wilson 17 years ago. I'm not sure if you remember completely, but maybe partially or fully. And you asked him a question, what is the greatest threat to biodiversity? And he answered with an acronym HIPPO, HIPPO. But I'm going to throw that question at you after 17 years. Now I'm interviewing you. What you think now is the biggest threat to our planet and biodiversity today?
Well, that's a hard question. One obvious and I believe that's the H in hippo is habitat loss. I
Mhm.
mean, that's just a very obvious one. You rip up a piece of the rainforest, you plow something down, you just destroy the habitat for whatever is living there. And some creatures have very small ranges, so you've just obliterated their whole habitat. But it's not always true that the most obvious things are the biggest threats. So, clearly climate change is a very big threat to a lot of species. Can they move fast enough in periods in the past of climate change? And the climate does change. We've had ice ages not that long ago. The method of choice for surviving that was to migrate, but and to try to track the climate. Um, but both because of the speed at which we're changing the climate and the fact that we have, also really seriously altered the surface of the earth. You put up a road, a lot of creatures can't cross a road. A road is a big barrier to a lot of species. You put up a housing development, you put up a city, you put up a reservoir, blah, blah, blah. You can see easily that we're getting into a situation where it's much, much harder to move. So climate change is going to be a big, big threat to a lot of species, and increasingly we're seeing the results of that. So habitat loss, climate change, moving things around the world is a big, big threat to a lot of species. We move goods, phenomenal amounts of goods around the world. We move ballast water around the world, and we just are sort of, there's nothing that's isolated anymore.
Mm.
And many, many creatures, evolved in isolation, and now they're being hit both by predators they can't deal with and by diseases they can't deal with. So, we have a lot of zoonotic diseases that we're worried are going to pass to people, but we also have a lot of wildlife diseases that are just being moved around. And, you and I, you're sitting in Eastern Mass and I'm sitting in Western Mass. And, one really good example of this is the emerald ash borer. It's not a disease. It's a sort of more of a predator, I guess you'd say, but it's a, insect that was imported from Asia, and it attacks ash trees, which are very prominent in New England. And it's just going to kill them all, really, pretty much all of them. And so we're radically changing the forest, and that's going to have knock-on effects because a lot of species depend on ash. So these threats just multiply and ramify. But those are three biggies. How's that?
So, is there like some of the species are more critical for the life on the planet than others?
Well,
And what
yeah.
are some of those which are like kind of really on the brink of extinct?
Well, this is this sort of concept of, keystone species or ecosystem architects, the species that sort of underlie, create the space that other species live in. And a very, very classic example of that is obviously corals, reef building
Yeah.
corals. There are many species of them. It's not a particular species, but there are many species of reef building corals, and many slash most of them are in a lot of trouble because of rising water temperatures. And we're seeing these coral bleachings. I'm sure your listeners have heard of that, where you get high water temperatures and the corals basically turn white. And if it lasts a long time, they die.
Yes.
And you're seeing a lot of coral mortality, and that will have tremendous effects on the many, many, many countless species that rely on reefs. So that's a very good example of a group of organisms that's really a crucial ecosystem, sort of engineer that's being very severely hit by climate change.
So, you said, I think, in one of the podcasts that you've been to Greenland. Is that recently for this book?
I've actually been to Greenland a few times, and I was there pretty recently, last summer, I guess it was.
And what is look like? What did you see there, and what are scientists saying about the Greenland ice sheet? Because there has been some headlines about, like buying Greenland, or maybe, like, and if it's also threatening many countries' security because of the sea level rise. So what do you see? What are the conversations among scientists about the Greenland?
Well, a lot of the science is focused on, what is going to happen to the Greenland ice sheet, which is contains enough ice to raise global sea levels by 20 feet. So we are talking about, a huge slug of sea level rise. Well, not a slug, you probably wouldn't get it in one slug, obviously, but the really big question with the Greenland ice sheet right now is, is it in a kind of irreversible
Mhm.
state of decline such that, its inevitable destiny is to not necessarily melt entirely away, but to become a much, much smaller ice sheet. And people are trying to look at that from in a lot of different angles, as it were. But, in the meantime, ice loss of Greenland is already a major contributor to sea level rise. And the question of, how much more, how that's going to grow and how quickly that's going to grow is really a very serious one.
So if we buy Greenland, then it will be okay, right?
Well, if we buy Greenland, yeah, no problem.
Yeah.
The reason I think that I don't want to claim to understand the mind of the Trump administration, but the reason that there are two potential reasons why you would be interested in it for strategic purposes, one of which it just has a strategic location, you
Mhm.
know, it's between us and the Russians, and it was always used as a listening station. There were a lot of radar stations there. There used to be a big U.S. base there. Now it's a much smaller U.S. base. Um, so it has military significance, and it also has potentially a lot of mineral wealth. And the idea is, as the ice sheet, shrinks, more and more of the land will be exposed, and the shipping lanes are becoming more open, and potentially you could exploit some of that mineral wealth. But I think people in the US government don't appreciate a lot of factors about Greenland, one of which is it remains extremely difficult to get around Greenland. There are no roads in Greenland, so it's very difficult to operate there still. And secondly, the Greenlanders, who are a sort of semi-autonomous nation within Denmark, they have their own, rules of doing things. They're very, collective society, and they have made laws about certain forms of extraction that would really make it quite difficult for companies to just come in and, for example, extract rare earths. So I'm not sure how much eagerness there is, even among mining companies, to try to operate in Greenland.
And which will also having a devastating impact on the planet and the environment and the ecosystem and the species, right? If we drill, if we go for those minerals and critical minerals and all that.
Well, actually, that I want to say is a very complicated question because some of those minerals are actually crucial to, the so-called green energy
Mm.
economy. They're crucial to, electric car batteries, even wind turbines. There's, these rare earths are in magnets that we need for a lot of different things to power, potentially clean energy. So it's not a cut and dry,
Mm.
thing. Now, that being said, operating in really remote regions where, it would be very difficult to contain any kind of damage is obviously raises the stakes on every kind of mining operation.
And you have written a book and you won a Pulitzer Prize, if I'm not wrong, on the sixth mass extinction, right? Um, and there has been many species on this planet before us, and some of them survived, some of them didn't survive, and the one we survived, we call them survivors, right? So why dinosaurs are gone, and why are we so locked in, or like kind of think that if some of these species which are still alive today, if they go extinct, and maybe there's another species in the 100 or 200 years or 400 years or in a millennia, but our survival as a humans, to what extent it depends on those survivals, and do we have a strategy for ourselves to survive on this planet?
Well, these are all, really good questions. I mean, as you know, we don't sort of go about these things with a plan. We just sort of, there's no grand plan here. We're just sort of doing them. And, the question of whether there are certain species, certain, sort of keystone species without which our own, you know, survival, I'm not sure I want to go as far as survival, but our way of doing things. I mean, one thing that's important to sort of think about is obviously there are more people on the planet right now than ever before, over
Yes.
8 billion, and so we're not talking about we're talking about a species that has a lot of needs.
Mhm.
And we've built this very, very sophisticated, interconnected, high-tech society that runs on energy
Yes.
and food.
Mhm.
And if you disrupt those, sort of, if you disrupt the food supply potentially, you have a lot of problems. So I think the question of, how far you can push the system before humans start to feel the impact of loss of species. Obviously, as you say, many species have gone extinct in the history of life. In fact, to a first approximation, all species go extinct eventually. And many species have gone extinct since humans started to notice, extinction. And the question of, does this start to bite at any point
Mhm.
to us as opposed to just to the world around us, which I think people should care about. Um, but even if they don't care about that, they might be concerned because, we're pushing things so, as I sort of said before, so far and so fast
Mhm.
that there really are very few precedents in the record for what we're doing. And usually those precedents, when you look back at them, were really bad times for planet Earth. I mean, they were times of mass extinction. That's really the point of the sixth extinction. If you look back in the geological record at what, at times when you had extinction rates comparable to today, they were not happy times for planet Earth.
Absolutely. And you've been writing about the environment, climate change, and the planet for decades, at least since, 25 years almost. Compared to early 2000s, where are we today? Are we really making some progress, which should be like stay hopeful that we can still manage to stay below 3 degree C before 2050 or 2100, or we are worse off than where we were in early 2000s?
Well, I sure hope we can stay beneath 3 degrees C, because 3 degrees C is a very different world, really, really dangerous, scary world. So, I think I gotta hope that we can still stay beneath 3 degrees C. Um, but I think that the difference between, now and 2000, let's say, is, we know a lot more. Um, we have made progress on some fronts in terms of, bringing down the cost of certain clean energy technologies. Um, but we have also, just continued to, CO2 emissions are still up. They're up every single year. So it's really hard to say, okay, well, we're making progress. People will say, well, we've made progress, that some of the absolute were, there were trend lines that were so bad that they were going to, lead off the charts. Let's say not by 2050, let's say, but by 2100, maybe some of those have been brought down, but those are completely theoretical. Those are trend lines, they're not facts. So we don't really know where we're ending up, and we don't show a lot of discipline in terms of making sure that we avoid some of those worst outcomes.
And in order to avoid those worst outcomes, we have to do something. Of course, we're making some progress, but many people would argue that it's not near enough, and the speed of that may not be enough. And many people, including myself, I have talked with another physicist who talk a lot about climate restoration and propose different methods to reduce carbon emission or to even capture the carbon from the atmosphere. And you also talked a little bit about in your book, right? If I'm not wrong, about the carbon capture. But on Daily Show, you said it's not viable. But then the question is, why are we relying or talking about a solution which doesn't exist or maybe not viable politically, financially, or technologically?
Well, I'm going to turn that question back on you. Yeah, why are we? Uh, I mean, I think the short answer is because there's a lot of pressure to, say, well, um, let's not give up. So, for example, 1.5 degrees was considered this kind of line that you didn't want to cross. There's
Yes.
a lot of dangers beyond that. It's obviously a somewhat arbitrary line, but it has, some pretty solid backing in the science. And we are crossing that. And
Yes.
so then, one possibility is you just say, oh, well, there goes that, and so that's over. Another is to say, well, the real issue, and this is true, it absolutely is true that, the big issue is how long you stay at 1.5. So you can go to 1.5, but if you just simply sit there for a long time, by human terms, then you're guaranteeing bad things. But if you could come down again, maybe you could avoid those bad things. But coming down through natural means takes a long, long time.
Yes.
So could we speed that up? And there's a lot of pressure to sort of say, well, yes, we can, and we can still avoid this. And humans are very, technologically savvy. We do all sorts of amazing things. So we'll figure out a way to do this. But, the fact of the matter is that it's not easy to do, and no one has done it yet. So it's
Yeah.
not the kind of thing that you would want to say, bet a planet on, and yet that's what we're doing.
And you also wrote an article in the New York Post, I think, about geoengineering. Yeah, sorry again, New Yorker. Yes. And I think Jeff Goodell also said that we have to try some small scale experiments. We have to do something. But other people say like, oh no, no, we can't do that. It's very controversial, it seems, but it's something out there. We haven't tried it. But do you think we should at a small scale to do something, as we also sometimes mess with cloud seeding, another method we do sometime. But like, what should we or should we not talk about or do anything with geoengineering?
I think that's a really hard question. I see really powerful arguments on both sides. Those people who say, you're heading for really bad times,
Mhm.
and if this could help, avert some of the worst of that, you are going to want to know, even, first of all, if it even works. I mean,
Yeah.
all these things are questions. You
Yeah.
would want to know that, and you can't. That's a very long-term research project. So that's a powerful argument. And there's also a powerful argument. Look, you are never going to be able to safely deploy this or, you
Mm.
know, equitably deploy this because you're never going to know
Yeah.
exactly what the ramifications are until you try it, at which point it's
Absolutely.
too late. And there's a lot of possibility for, global conflict here. Um, and there's very little, it seems right now that a global governance scheme seems uh, that seems like a very much a pie in the sky kind of idea at this particular moment in time. So I can see very powerful arguments both for doing, small scale experiments and for saying we are just not going there.
And what's the argument? And I think it's kind of similar argument about nuclear. Some people saying that it's too late, it's too costly, it's like too dangerous. Other people say like, but it's like, we have to do something as long as it meets our energy demand. So what do you think about that?
I think that's also a very difficult question. I mean, nuclear is very expensive, and we've never solved the waste problem. All of the waste in the US, all of the spent fuel rods are just sitting there in at the nuclear power plants where they were generated, where they were, irradiated. They're dangerous for quite a long time. Um, So, we've never dealt with that. There are people, that I respect a lot who say we've got to go, full on nuclear. And there are people I respect a lot who say that would be a disaster. Nuclear also raises, nuclear proliferation issues. So nuclear is a really complicated one. China is building a lot of nuclear. We are talking about building nuclear, but, I see it is a very, very slow process here in the US.
So people who call themselves doomers or collapse, they would argue like, oh, look at that. See, like either these solutions are not viable or they're too complicated or we're not trying them. That's why the collapse is inevitable. That's why we are heading towards something where we are like already getting too late, right? And I see the argument there too, because if you look at the overall picture of these solutions or like things we can try, they're not moving anywhere so far, whatever we have, seen in terms of technology. But I want to ask you, you have written extensively on very wide range of issues, geoengineering to COPs, and you also attended the recent COP, right?
No, I did not go to the
You did
last.
not, you just wrote an article on that about Trump and climate, wildfires, hurricanes, fossil fuel companies, all of these issues. For a general public, it is so much, hurricanes, ice melting, these plastic pollutions, like now the energy demands of AI data centers. How do we literally square and like kind of not to overload them with information about this? We know it's complex, it's too much, it's so big. How do we best possible way to communicate to ordinary people about this issue?
That's a good question too. I mean, it is really overwhelming. I cover this stuff, for a living, and I find it overwhelming. So I understand that people have a limited, sort of bandwidth for the latest, disastrous news, or, as you say, there's a lot of news now about AI's energy demands, which are huge. Um, I think that, this is why having, a functioning government is useful. I mean, people need to, in a very in a really complicated, technological society, we have to be able to trust various regulatory bodies to act on our behalf, because we can't all be up on these things, and we can't control them either. They if I say, well, I don't think that this should be done this way, obviously that doesn't make much difference. So that is why, I always tell people you have to engage in the political process. You have to elect people that you think will themselves and will, appoint people to regulatory boards, public utility boards, et cetera, who will protect the public's interest. And, we are in this weird, very scary moment where a lot of those things are being dismantled just at the point when we really, really need them more than ever.
Yeah.
So, I sympathize with those who say, we're just running sort of pell mell, as fast as we can toward some kind of massive disruption. How's that? We'll call it that. And just, disruptive has become, kind of a good word. But actually, if you live through massive disruption, I don't think you think it's actually very pleasant. And so I certainly worry about that a lot.
And you see the reports from WMO, IPCC, Chatham House, all those reports, and then you also look at, different like wildfires in, Canada, US, Australia, and now the East Asia is devastated by the flooding. And you write and you come across with the first-hand information, and also you travel and see these places. Where do you stand in terms of have you become a climate realist or a doomer, or there are people who are very depressed about that, having anxiety, and it's like, you know what, we can't do anything about it. How do you keep up with this so much for your mental, emotional, physical health as a writer and seeing those things, every day?
Well, one of the things I try to convey in Life on a Little Known Planet, this latest book, is, we live on a really, really interesting planet. It's a really interesting place. And whenever even things that when I go out to write a story, even one that is about something that is ultimately, kind of depressing, there's a lot of, I try to see what's interesting about it because the world is such an interesting place. And I guess that's how I, keep going, even in the face of a lot of bad news. And, the other point that I would make is, we don't really have a choice. Giving up is, um, it is an option. I don't want to say it's not an option, but, I have kids. Many people have my
Yes,
age,
I
and,
have kids too. I have
you
two
have
boys. Yeah.
kids. Yeah. And your kids are probably younger than my kids, and they have we have kind of an obligation to them to, we've really messed things up, and we
Yeah.
have an obligation to them not to just say, oh, well, sorry, we're handing you this planet that
Mhm.
is going to be, not exactly uninhabitable, but really, really a much, much more unstable, much more dangerous place. And, you hear this a lot in sort of climate circles, such as it is, every tenth of a degree matters. So you can't just say, well, we've passed 1.3, we throw up our hands. You have to keep uh, fighting, yeah, for improvement.
And my last question would be, what is something you think we're still not spending enough time talking about climate and the planet, and we should be spending more time as a society?
Well, I think that the big looming, threat is that there are a lot of, we sort of touched on this when we talked about Greenland. There are a lot of systems that um, have, positive feedback loops that you can get going. And are we setting these positive feedbacks, in motion in such a way that, have, we will lose control over it doesn't just matter how many degrees things warm, it also matters what what um what these systems what they're capable of doing once you sort of start rolling them downhill, or however whatever metaphor you want to use. And that's something I think we really need to worry about, and I think that has climate scientists very, very worried.
We have to leave it there. Thank you so much, Elizabeth Kolbert. I will put the link for the audience in the description, and I'll highly recommend the book for everyone to read and to know more about the small, beautiful little planet. Thank you so much.